Hey, this is Mr. Ng going over the Precalc Quiz number 4, sections 1.1 to 1.2, taken October 17, 2017. It's out of 36 points. Multiple choice, circle the best solution. Question number 1, determine whether the equation defines y as a function of x. So they want to know, is it a function? Well, if you graph it, it's going to look like an even function there. It passes the vertical line test, it's 1 to 1, so therefore the answer is A. Notice the student got B's incorrect. I don't see any pictures or anything that might help that student. Question number 2 says, determine the domain of the following relation. Relation is just a function. X relates to y, y relates to x. So domain is following the x-axis. You go from left to right. So if you're going in this direction, you're going to start here, has a closed circle. Closed circles are brackets because this is all interval notation. So I'm just focusing on the x values or the x number line, so that's at -4. Notice you keep going and you stop here on the graph. It stops here at +3, and because it's an open circle, that'll be a parentheses, that'll be choice B. I liked how this student wrote the word, they recognized it was a closed circle and an open circle to remind themselves. Number 3 says determine the range of the following relation. So range refers to the y-axis, and the direction we talked about is going from bottom to top. So notice how I labeled down here, these are negative numbers. Really far down, that's negative infinity. As you go up, the first thing you're going to touch on the graph is this arrow. So that's telling you from negative infinity, and as you move up, the last thing on the graph is here on the y-axis at 2. And so it's a closed circle, you're going to use a bracket. So start here, negative infinity to 2 is your answer. Remember, 2 is not included, so that's, or 2 is included, closed circle, that's a bracket, and your choice is B. Student got the problem wrong, and they wrote from a couple of things here. They said T to B, so I'm thinking they're actually going from the top to the bottom. At least they knew it was the y-axis. But then here they switched it. They go from -4 to infinity, and they're going this direction. That's the domain, so that would be incorrect. Question number 4 says graph the given match the given graph with its polynomial function. So the first thing you should notice, you could just put in those calculators and you can just actually graph each one of those, but you should be a little bit more strategic. The first thing you should think about is that B and D are odd. This is an informal definition I gave you. That means it acts like any other odd function. Like the easiest one is x to the first power. So that means it would start down and then end up, right? This with a negative sign, it just switches it. So it would start up and then end down. So you're left with these two choices here, and both of them have a y-intercept at +10, so you could eliminate that one because that's a -10. And then you're looking for x to the 4th is an even, so it acts like x squared, like a parabola, so it starts up, ends up, and that'd be their choice C. A would be actually facing down because of the negative sign. Number 5 says the graph of a function is given. Decide whether it is even, odd, or neither. So to determine the symmetry, this is a symmetry problem. If it's even, odd, or neither, there's a couple of things. Number 1, you can do algebraically. So algebraically, if you recognize this graph, it is a quadratic. Have a parabola opening up, so that would be y equals x squared. And then to solve this algebraically, you're going to substitute a negative x and see what happens. So negative x squared, so that's negative x times negative x gives you positive x squared. So it comes out to be the same. I think of kind of like ends up the same or ends up even. A would be your answer. If this became the opposite of your function, that would be an odd. And if it doesn't turn out to be the function itself or the opposite of that function, that would be a neither. Now another way you can answer this problem, 24 shouldn't be there, is graphically. Notice how it is on the y-axis, and a symmetry is on the y-axis. So I give you guys a silly phrase, evenly. This line here represents the y-axis, which you can fold it on. Now be careful, the parabolas are symmetrical anywhere, but we're specifically locating symmetry on the y-axis. So that line right down on the y-axis, that's where you fold your taco and fold it in half. Their answer is even. Here's some interesting work. This student identified the correct y-intercept, but they wrote 0, 3, and then they wrote 3. So maybe they were thinking that this refers to the y-intercept, but that'd be incorrect. We're looking at symmetry at the y-axis. Question number 6 is, how is the question number 4 bounded? So bounded just means that there's no arrows going in that direction. So in this problem, you're asked to look at question number 4, this graph up here, and you'll recognize that there are no arrows down here. My example in class is that if you had the lunch lines or lunch boundaries, notice how there's no arrows. Students can't go here. Students will go towards it and they might see an assistant principal and they walk around, okay, I can't go there. So this means that it's bounded below. Now this problem, if you look over here, the reason why it's not letter choice J, because it says unbounded. Unbounded means there's no boundaries, which means the arrows are there. So that would be not the case. That would be the case for choice A here if it was actually flipped. K here says only bounded below, so that means it's only bounded here. Now I said that you can say unbounded above and bounded below. So we talked about kind of like both, right? You can kind of use that terminology right there. So I said none of the above. So it's bounded below and unbounded above. This is somewhat true, but not completely true. In work right here that shows they put unbounded and they wrote bounded down here, and then they wrote those details. So they realized it's none of these, so that'll be L. This is question number 8. It says, which window? The graph of f contains a local maximum and a minimum, so I need to find a graph that has that. Which window would you use? So here's my polynomial negative x cubed minus 20x squared plus 75x plus 800. And when I graph it with a 10 by 10 window, so 10 going either direction and then 10 above, we call that a 10 by 10 window. Notice how I can't see a minimum or a maximum. So if I change my window, I'm just using Desmos, and so it's a little bit different. So I change the window to on the x values, the x minimum negative 20, x max 10, y min negative 2000, y max, whoops, that should be 1200. Let's take a look at our graph. And in our graph now you can actually see a local minimum and a local maximum. The multiple choice answer is the second one. This is what your graph would look like if you chose the third option with a window of negative 20 to positive 5, and then down here I have negative 1000, which you can't see, so it's a little bit off, and then positive 1000. So all you can see is just the local max. Question number 7 is talking about taking this polynomial, graphing it, looking at the window, so the answer is the second one. I like this student work because the student actually sketched each of the windows, so I'm assuming this was the first one and this was the second one, and they can kind of see it has a local max and minimum, and this one only just had a local max. So 7 multiple choice times 2 is 14, 2 points for writing your first and last name neatly, and 1 point for the period, so that's 17 points for that side. All right, question number 8, for your response, make sure to show all your work and box your answers. Number 8 tells you to graph f of x, and it gives you 2 pieces, negative x minus 1, and RD stands for this is your restricted domain. This tells you if x is less than 1. And then f of x equals at x squared minus 6x plus 8 if x is greater than or equal to 1. So the first thing I'm going to do is recognize that they both have a value at 1. So this dotted line here at x on the x-axis at 1 is not an asymptote, but it kind of tells us this boundary direction. And because my piecewise function only has 2 graphs, that basically means you're going to have one on the left side and one on the right side. So if you had 2 graphs on one side, you know that something's wrong. So to graph these, negative x minus 1, you're going to go ahead and start at negative 1 as your y-intercept, and you're going to have a slope of down 1, right 1. Or you can also say up 1, left 1, because it still has a negative slope, okay? And you have this whole line here, and then it tells you if x is less than 1, which means that I need numbers that are less than 1, that's to the left, which means you're going to erase everything over here. That is less than, so there's no line there, so that's going to be an open circle. To graph x squared minus 6x plus 8, you can do a couple of things here. You'll recognize your y-intercept as 8. I'd rather go with the x-intercept, so if you factor it, you'll have x minus 4, x minus 2. So set those equal to 0, and you get x equals 4 and 2. and then that midpoint, which is 3, that'll be your line of symmetry. So then you can use your calculator, or if you put in 3 into this function, 3 minus 4 is -1, 3 minus 2 is 1, so -1 times 1 is a -1, so 3 comma -1, I should have wrote that right there, is your min max vertex. So then you can go ahead and graph your parabola. Remember, you can always use your graphing calculator to get points on there. And then at 1, you need values that are bigger than or equal to 1. So that's a closed circle, and then everything to the right. So that means this part over here, you would just erase. I gave you 3 points if your graph looked okay, with the restricted domains correct, but you didn't have any open or closed circles, or maybe those were incorrect. I give you 2 points if you graphed one of these correctly. So I'll usually put a check if you did the linear, and then maybe you got parabola wrong. Even if you graphed on the wrong side, so I'll give you credit. Or maybe you graphed both of them and didn't do the erasing, or you didn't understand the open or closed circle. Essentially, if you got something right, I gave you 2 points. On the bottom there, it says continuous or discontinuous. If discontinuous, what type? So to get your 1 point, you had to have both discontinuity and jump. A lot of students just wrote discontinuity, okay. Then it says if discontinuous, what type? You didn't tell me what type. It's a jump. It's a jump because you have to jump back up there to get back on the roller coaster. I wanted to show you the student work here. So this student, they graphed it by their intercepts. They got the linear, put it in there. They put if their y is equal to 0, what is your x value? And when they did that, they got x equals -1. So yeah, that is yours. But here, I took off a point because the student didn't recognize their restricted domain. So maybe they actually drew a line there, but they didn't use it. They had one at 2 and -1. I think I know what they did. They made y equals 0. So you're actually finding your x. They're finding their x-intercepts, which is incorrect. It helps you graph it, but they actually use that as their restricted domain. See, they put in 0. I don't know. They got +2. This one's correct. Try to use that line right there dotted. That would be helpful. All right, this student work here. That's interesting. They graphed this one correct, so I put a check mark. 2 points for getting that one correct. And then over here, they have a line, so they couldn't even recognize that was quadratic. Power of 2. You should have a parabola or a U. So incorrect there. And then again, they wrote discontinuous, but didn't tell me jump, so I gave them a 0. This student here lost a point, graphed them correctly, even erased it correctly, but just didn't have their open and closed circles. Student lost a point here. They didn't tell me if it's continuous or discontinuous. They just said jump. So the student graphed a parabola, but the reason why I only gave him 1 point for trying, I didn't give him 2 points for a correct one, although the parabola is opening up, their vertex is incorrect. I think we calculated it to be at 3, -1, so they were off. Here I wanted to show you that the left side was graphed correctly with the check, and then this side was graphed incorrectly. This student work, I wanted to show you that although they didn't graph the parabola correctly, I mean, at least they erased the left side, I wanted to show you that you should not have 2 graphs on one side. Question number 9 says find the exact distance between points C and G. So here's C, here's G. C has -3, -4, and then G has the order pair 0 on the x-axis, 2 on the y-axis. So have my order pairs there. And then you can use Pythagorean theorem. Well, Pythagorean theorem works for right triangles. Right triangles, the equation c² = a² + b². Again, guys, write down the formula so you can get at least partial credit for identifying the correct one. Here, my short leg is A, so that's 3. My B value, you count up there, the distance of 6. And then your C value that you're trying to find is the hypotenuse, which is across the right angle. So then 3² is 9, 6² is 36. 9 + 36 is 45. So c² = 45. Take square root of both sides. You get C equals square root of 45, which can be simplified to 9 times 5. The square root of 9 is 3. So this is an exact answer. If you did it in decimals or the square root of 45, you got 3 points. All right, so you can always use the distance formula. D equals the square root of x2 minus x1 squared plus y2 minus y1 squared. This is the, doesn't matter, 2s subtracted by the 1s, or the 1s subtracted by the 2s. I call my first order pair G02, and my second order pair -3, -4. And when I substitute that in there, so x2 goes in first, -3, x1 is 0. Don't forget it must be a subtraction sign there. It's not just for your convenience. So -3 minus 0 is -3, and -3 squared is 9. Second order pair is -4, and first one is 2. So -4 minus 2 is -6. -6 squared is 36, and you get the same thing. So you got a lot. You lost a point if you either put it in decimals or again put it radical 45. Here's an example of a student who got 3 points because they didn't simplify. Student wrote down the correct formula, but substitutions were incorrect, gave them 2 points. Closely looking at this one, I think y2 minus y1 over x2 plus y. Is that an x2 minus x1? So substitutions are incorrect. Student here rounded to decimals, doesn't say round to the nearest tenth, incorrect. Another student example, student didn't have the formula. Remember, you're allowed to have formula sheets. Student here was trying to find slope. Slope refers to the pitch of the line. I'm trying to find the distance between point C and G, not slope. Question 10a is just asking you to graph the following function and identify the intervals in which the function is increasing and decreasing. So if you put that into your calculator, well, in order to find, I just gave you 4 points. It should have gone through the origin. You put it in 0, then you get all zeros, so 0, 0. And then, although you didn't have to find the local min and the local max and local minimum, you could have just used the function on your calculator, and you could have. I'll record it in 10 seconds, but you need that so you can get increasing and decreasing. So Mr. Ring's showing you guys how to do question 10a. So I'm going to y equals, and then I have xxx minus x squared minus 2x zoom 6. We can change our window here. Could probably go to a minimum of -4, max 4. Alright, it's a better looking graph, and then it's asking me in 10b to find where it's increasing. So to find where it's increasing is this part right here, and then this part to this part. So in order to do that, you're going to have to find your local maximum and your local minimum. So let's go ahead and do that. So I can do trace. Now, a lot of students, I think, are doing this, right? You just press trace, but remember, you're pressing second. Let's try that again. Second, calculate. No, try that again. Second, calculate. And it brings you up this window there, and then I'm going to do the maximum. So let's go to 4, or you can just press 4. Now it says the left of it, enter, and then you go to the right of it, enter, and exactly between, or what you think it is, your guess. And that's how I got on here, x equals -5.5 rounded up, and your y coordinate is y equals 0.63. Remember, you don't need the y coordinate because for increasing, you're going from the x value, so -infinity to -0.55. And then to find this local minimum, again, second, calculate, and do the minimum. And then you're just going to go to the left of it, and then to the right. And exactly where you think it is, press enter, and it'll get it for you. So x equals 1.21 and y equals -2.1. So a lot of students were kind of just estimating whole numbers, and that was not accurate enough. So that's how I used my calculator. So where it's increasing is from left to right. So increasing and decreasing only focus on the domain. So -infinity to, you're only looking at the x value, so -0.55. And then it's also increasing from 1.22 towards the arrow, which is positive infinity. It's only decreasing from here to here. Again, you're only focusing on your x value, so -0.55 to 1.22. And again, you're not including those because it's not increasing nor decreasing at those points. These are backwards, 1, 0. We're not finding x-intercepts. All right, the student graphed it correctly with even the local max and local minimums there. But then when they came here, they identified the y's. So they went from negative infinity, and then they did it to the y coordinate. So remember, you're going from the x values because you're going from left to right. Where is it increasing? So this person was wrong because they did the x's. It should have been they used the y's. It should have been the x's. That's 2 question number 10s. Oh, this should have been number 11. Graph the function. So I give you 2 points for that, and then make sure you include asymptotes. Asymptotes are vertical and horizontal, 2 points. So you need to show me how you found those. So some students did this. You could circle it. Looking at the exponents, that's a 1 and that's a 2. 1 is less than 2. I showed that right here. Therefore, you have a horizontal asymptote at y equals 0. I put that in green. So y equals 0 is actually on the x-axis itself. All right, the second thing you can do is find the vertical asymptote. So you have a rational function, reciprocal function here, and the issue is if in a fraction, if you have the denominator equal to 0, that's a bad thing. So if you take it and you set it equal, not equal to 0, we talked about it in class, I should have not equal to 0 there. And the easiest way is if you realize I gave you one that factors, so go ahead and factor that first. And then you set each of those equal to not equal to 0. So x cannot be -5 and x cannot be 4. Those are your vertical asymptotes. These are vertical asymptotes because if you put in -5 there, that's 25 minus 5 gives you 20. 20 minus 20, and then that would be -4 divided by 0 is undefined. So that's where my asymptotes are. And you can use your graph calculator to get a sketch like that. And so you got 4 points if you graphed it and showed how to find both asymptotes, vertical and horizontal. So show me something, right? I give you 3 points if you didn't show why the horizontal asymptote. So I even gave you full credit even if you circled the highest degrees or powers. No A on G. I don't know what that means. No asymptote on the graph. So if you don't have an asymptote on the graphs, then so if you just put this in your calculator and then you got those in blue, I gave you at least 2 points. A common mistake among students, which I'll show you in student work in a second, is they try to find symmetry, which they try to substitute an negative x and see what happens. So I gave this one full credit. Notice they circled the highest degrees, wrote something at least. I would have liked to see the asymptotes and dotted lines, but they showed that by factoring. And then zero product rule, could set it not equal to 0, but they have those solutions right there. This one's going crazy. It gave me a bunch of colors. I kind of see the graph there. They couldn't get the graph inside the middle between the asymptotes. They were trying to find the intercepts here, but I don't see any asymptotes. I think they were trying to estimate with their calculator. Don't use red, guys. I'd appreciate it. Here's an answer directly from the graphing calculator. Although it's graphed correctly, you're not showing me or proving to me the asymptote, so I gave you 2. Some good-looking student work. Definitely do that. I wrote HA there for horizontal asymptote for them to show me how they got that. All right, I want to show you that even though this student only got a 3, asked more of the horizontal asymptote, but I want to focus on their finding the vertical asymptote and their work very deep. And they recognize that if they put in 0 there, it's undefined at each of those at the asymptote. So I like that. Here's an example of a student. I was like, what are they doing here? And I realized what they're doing. They were trying to find symmetry. And notice here, the problem doesn't ask you to find symmetry, but I know the student is because for every x value, they put in -x. Do you see it? And they said it was not in the original function, so it's neither. So it's just to show that there is no symmetry in this problem, but I wanted to show that the student didn't understand what they were being asked to do. I did give them 2 points because they probably just put in your calculator and punched out a solution. All right, so question number 8 up there, 4 plus 1 is 5, plus 4 is 9 up there. You got 4 points for the graph here, 9, 13, 14, 15 points, and this question that's supposed to be 11. Another 4 points, so that's 19 points. and then that means your quiz is out of 19 plus 17 gives you, remember that should have been 36. Hope that was helpful.